Hi there, the Math Dog here. In this video I'm going to look at an introduction to transformations in a series of videos I've done on rotations, translations, dilations, and reflections. So I actually did another video on transformations, intro to transformations, where I actually took a compass and protractor and rotated things around a given point, say 70 or 30 degrees. In this video we're going to do in multiples of 90 degrees, and we're not going to use a compass protractor. We're going to use an analytic technique to do that. And the reason I'm doing this topic, one of the main reasons I'm doing this topic, is it shows up on the Common Core state math tests, where you are asked if you rotate a point, say 90 degrees counterclockwise, what's the new point? So let's get started. So there are four basic types of transformations. If you've watched my other videos, you could skip this. I've been through this. A transformation can have multiple steps. For example, you could put together what we call a translation and a dilation. A translation is also called a slide. All a translation is, a slide is, if I have a figure, I move it, the figure still is congruent to the new figure, is congruent to the original figure. All we've done is move it. Congruent means same shape and size. The dilation, you start with a figure and you either shrink it from the original figure or you magnify it. So a shrink or stretch. A reflection creates a mirror image of some figure. So if I have a figure like this and I reflect it over this line here, the left is the mirror image of the right, and this is my mirror. Okay, then what we're looking at here is a rotation, and we're going to do them. All our rotations in this video are around the origin 0, 0. Okay, so again, I look at rotations about the origin using analytic techniques. So we have our original image, which we call the pre-image. We're going to rotate it. Each point we're going to be rotating either clockwise or counterclockwise. The way I've done it here, I could go clockwise this way, or I could actually go counterclockwise all the way back this way. So just sketching it here, so like Z to Z prime, let's use a different line here. From the origin, Z to Z prime, we're rotating, if we go counterclockwise that way, and that's going to be so many degrees. And essentially we're actually doing 90-degree rotations here, so we're moving. This is not a 90-degree angle here. We're actually going to be moving everything 90 degrees or some multiple of 90, like 90, 100, 270 in this particular video. Okay, first let's talk about rotating points that actually fall on the X or Y axis and rotating around the origin by 90 degrees. So the rules that I'll talk about, or how to do things I talk about in the rest of the video, do not apply to points that are on the X or Y axes. Okay, or what if we had we're rotating a point 0, 0 90 degrees? Well, it's not going to go anywhere. It's just going to stay where it is. But the best way to do something that falls on the axes is to draw a circle. So I've done that. All these points are equal distance from the center, so forget the numbers on a number line here. I'm just going to call this A0. This would be 0A at 90 degrees. This would be 180 degrees counterclockwise. That's coordinates negative A0. This is 270 degrees counterclockwise, because counterclockwise is going this way. This would be 0, negative A, and then back to A0. You could go clockwise this way. Okay, this would be A0, 0, negative A, etc. So if you had on your test, say the ISAT or M-STEP, whatever depending state you're in, like it's an SBAC Common Core based test, you might get something like this. It says, okay, if you rotate the point 0, 5 90 degrees counterclockwise, what's the new coordinates going to be? Well, it's just faster, I think, and easier just to draw a circle and figure out what the coordinates are going to be. So this is the x-axis, this is the y-axis, this is going to be negative 5, 0. This would be 0, negative 5. This would be 5, 0. So if they said, okay, you're at 0, 5, rotated 180 degrees, you just go, okay, that's half a turn, that puts me at 0, negative 5. 270 degrees would put me at 5, 0, etc. Okay, so the rest of the video we're talking about points that are not on the origin. Alright, so we're going to take a single point here, AB, we're going to rotate it 90 degrees counterclockwise. CCW stands for counterclockwise, CW will stand for clockwise. We're going to rotate around the origin right here, 0, 0. Okay, so what I've done here is here's the coordinate, here's the point AB. So I'm gonna pay attention to quadrants here. In a XY grid system, we call this Q1, quadrant 1, the first quadrant, second quadrant, Q2, third quadrant, Q3, Q4 is the fourth quadrant. Okay, so this section here is Q1, this section here is Q2, this section here is Q3, this section here is Q4. So this is actually very important in classes like trigonometry or courses like trigonometry or to study a trigonometry. But right now we're just worried about, okay, so this point is in quadrant 1 and X and Y, X being this way, Y being this way, any point in here has a positive X and Y coordinate. I'm going to be moving it, if I go 90 degrees, I'm going to be moving it into quadrant 2. So quadrant 2 now, X goes to negative because it's over here, but Y stays positive. So what I'm going to do is I've drawn a right triangle here, so this is the horizontal movement A, the vertical movement B, and that gives me the point AB. So what I'm going to do is I'm going to copy this, make a congruent triangle, copy this triangle we had, and get it to move. So this is a congruent triangle, and I'm going to rotate it in such a way, like this, and put it there. Now, notice that angles A and B here, I've labeled these A and B. A will be opposite, or angle A will be opposite little side A, little b will be opposite angle B, etc. So this is a right angle, so A plus B has to be 90 because the sum of the interior angles of a triangle is 180. So A plus B are complementary angles. Therefore, these two angles here are A plus B, they're 90 degrees, so therefore that means that this has to be a right angle here. So that means we're performing a 90-degree rotation, and these hypotenuses of these triangle, or hypoteni, whatever, of these right triangles are congruent. So the coordinate of my new point is going to be, I'm a little off in my accuracy here, but it's going to be right here. Okay, well, what are the coordinates of that point? Well, this is going to be the negative of B here. And this is going to be positive A. Okay, you can count. Actually, I've used 4 units here, 4 units here. So this is going to be little a. This is be negative B. So the coordinates are going to be negative B, A. Okay, so doing a 90-degree rotation counterclockwise from first quadrant to second quadrant, notice what happens. Okay, so in my case, I'm going from AB to negative BA. So in general, what I'm doing here is notice that A gets moved to the Y position. So X gets moved to the Y position, and then we take the negative of Y. So this is the rule. Okay, so rotating a point 90 degrees counterclockwise from Q1 to Q2, XY becomes negative YX. Okay? Alright, so now we're here. Okay, so we could label this also. This is going to be A, this is going to be negative B. So now I'm going to rotate from quadrant 2 to quadrant 3 90 degrees, this point negative BA. So again, notice quadrant 3 now, X is negative and Y is negative, so I have negative negative here. So I'm going to take, again, a congruent triangle, and I'm going to rearrange it in such a way to get something like this, okay? So now, A plus B, they're complementary. So you know this is 90 degrees again. So, and this is the hypotenuse of the triangle. This is the hypotenuse of the triangle, so they're congruent. So my new point, my 90 degree rotated point is right here, and the coordinates here are going to be, again, now this is negative A and negative B. So this is negative A, negative B, okay? So let's look at this again. So this is x, y in general. This is x. Well, let's do our specific here first. So we're going from negative b a to negative a negative b. So what's happening here? So the x position gets moved to the y position. So that means that this goes to here. So x goes to the y position, and then y goes to the x position, and you take the negative of it. So we get negative yx, okay? So now let's talk about rotating a point. That was 90 degrees. So now let's look at our diagram and talk about rotating the point 180 degrees. Okay, so if we started here, AB, notice that it's just negative A, negative B. So when you rotate 180 degrees, you start with x, y, and it becomes negative x, negative y. Now notice this 90 degree counterclockwise rotation. It's actually the same as what we got from when we went from quadrant 1 to quadrant 2. It's the same thing when we go from quadrant 2 to quadrant 3. Okay, so that the rule doesn't change. So now let's go from quadrant 3 to quadrant 4. So here's what we just did in quadrant 3. Now I'm going to create a congruent triangle. I'm going to move it into position, and I'm going to rotate it like so. Again, since these angles, this has to add up to 180, and A plus B are complementary, means they're 90 degrees. I know this rotation is 90 degrees right here. I know that's a 90 degree rotation. Now the coordinates at this point, in quadrant 4, x is positive, y is negative. So this is going to be coordinates of this point right here. I'm a little off in where I've got things here. Let's get that a little, this isn't precise. It's meant to be, but those are little cutouts I made. So this is going to be B negative A based on what I've done. Okay, and in quadrant 4 again, x is positive, y is negative. Okay, so let's take a look at what we did here. So if we go from negative A, negative B to B, negative A, what's going on? Well, notice that x gets moved to the y position again. Okay, and y, you take the opposite of it from negative B to B here, so we go from y to negative y. And again, if you remember back, this is the exact same thing we did when we went from quadrant 1 to quadrant 2, from quadrant 2 to quadrant 3. So it's a consistent operation. To go 90 degrees counterclockwise, we swap the coordinates and we take the negative of the new x coordinate. Okay? And if we had to rotate a point from quadrant 2 to quadrant 4, notice again, we have negative A, negative B, we go to AB, so we're making it negative x, negative y like we did before in the last example. So this rule also will be consistent. It's going to be negative x, negative y. So let's do a counterclockwise rotation summary. So counterclockwise rotations are going this way. Okay, the opposite the way a clock runs. So I'm looking this way. So I'm going from here, let's just take AB again to negative BA. Okay, so again the x coordinate gets moved to the y position, and then the y coordinate gets moved to the x position. You take the negative of it, and this is true all the way around. So like here, this gets x coordinate here gets moved to the y coordinate. The y coordinate gets moved to the x coordinate. You take the negative of it, and you just could keep doing that forever in the counterclockwise direction. Now let's talk about the clockwise direction, which is the opposite way. Okay, so now if I go this way, things change a little bit. The coordinates don't change. But now let's say I go from AB, let's do from AB here to B negative A. Okay, so now notice that the X coordinate moves to the Y position, and you take the negative of it, and the Y coordinate moves to the X position. Okay, so from here to here, I just demonstrated that. So let's just show one more to show it doesn't change. So here, notice the X coordinate gets moved to the Y position, you take the negative of it, and the Y coordinate gets moved to the X position. So here are the general rules for 90-degree. This should be actually counterclock. This actually, okay, so now let's summarize counterclockwise 180 degrees, which could be from here to here. Notice I'm just changing everything to the opposite of it. And if I went from here to here, I'm doing the same thing. I'm just changing everything from the opposite of it. So the general rule for 180-degree rotation is negative x, negative y. Alright, so now let's go clockwise. We've been going counterclockwise pretty much most of the day. So let's go this way and summarize what's going on when we go clockwise. Okay, so let's just start here at AB and go to B negative A. Okay, so again, notice that x here gets moved to the Y position, but you take the negative of it, okay? And then Y gets moved to the X position. So you're swapping the coordinates and you're taking the negative of the Y position. 180 degrees, nothing changes from the last one. It goes, if I start here, go 180 degrees clockwise, take the negative of X and Y. So that's the summary of the rules for clockwise 90 and 180 degrees. Now, I don't think it's a good idea to try to memorize this stuff. You might be able to memorize this one, but I frankly don't memorize it. I get it confused unless I have to derive it, and I don't have time to be deriving this from scratch all the time. If you were doing this over and over and over again and you had to write a computer program, then that would make sense. But this is a suggestion for the Common Core test, the SBAC and the PARC tests. There are multiple choice questions like this. So what I would do is I would identify the sign of x and y by the original point's quadrant. So for example, my original point was here in quadrant 2. I know x is negative, y is positive. Okay, then what I would remember is you're going to flip x and y. It becomes yx, and you put the sign of x and y in that quadrant. So we're going to do some examples of what I mean here right now. So suppose I have a triangle ABC, I want to rotate it 90 degrees counterclockwise. Well, that's one thing you do want to pay attention if you're doing an assignment or a test. Which way are you going? You're going this way. So let's list our quadrants here, because some of these points are in different quadrants, and that's going to make a difference. So let's label our quadrants. So this is Q1, that's positive, positive. Okay, A is in Q1 and B is in Q1. Okay, so in Q2, that's negative, positive. And so A and B are in Q1, so they're going to end up being the result of A's rotation is going to be A prime, and the result of B's rotation is going to be B prime. Okay, so what do? So I said you swap the coordinates of each point, and then you take the negative of the, well, in the second quadrant, x is going to be negative, y is going to be positive. So let's get our original coordinates here. So A has coordinate 3, 4. B has coordinate, that's supposed to be 8, 1. C has coordinate, now C is in a different quadrant. So before I get going there on that, quadrant 3, x and y are both negative. So C is in quadrant 3, but it's going to end up in quadrant 4. C prime's going to end up in, this is Q3. So it's going to end up in Q4, which is positive, negative. Okay, so C prime's going to end up over here. So let's go ahead and do this. So this is going to, A is 3, 4, so A prime is going to be negative 4, 3. Okay, so let's plot that. Okay, that's going to be A prime. B, I swap it, that's going to be 1, 8. Okay, but it's going to be, because B prime, because quadrant 2 is negative positive, this is going to be negative 1, 8. So let's get that put in there. Negative 1, 8 puts us right here. That's B prime. Now C, the coordinates of C are negative 4, negative 4. Okay, and you're moving it into quadrant 4. So again, you swap the coordinates, and in quadrant 4, it's going to be positive, negative, so it's going to be 4, negative 4. Okay, so C prime is 4, negative 4, which puts us right here. All right, so now we connect our points. And this is our triangle that's been actually rotated 90 degrees, okay, using the method I just discussed, okay? So now let's rotate, this is another example. I should have written example here, I will do that. We'll do that if I can. Okay, so we're going to rotate triangle XYZ 90 degrees, this time clockwise. Be sure you identify which way you're going. So we're going this way this time, around the origin. So we're always doing these rotations in this video around the origin. So let's get the coordinates of X and Y. I think that's the first thing I'm going to do here. So that's negative 4, 2 for X. That's going to be negative 2, negative 4 for Y. And then Z is going to be 5, negative 1. I like that Y. Let's fix that. That's negative 2, 4. Okay. So again, so we are going this way. So let's label I'm going to label my coordinates here, my quadrants. This is Q1. That's plus plus. Q2 is plus minus. Q3 is negative negative. And Q2 is negative positive. Okay, so X starts in Q2 and it's going to go, we're going clockwise this time, so it's going to, X prime is going to end up in Q1. It's going to go one quadrant over. Z is in Q4. And it's going to end up, Z prime's going to end up in Q3. Okay, then Y starts in Q3, is going to end up in Q2. Y prime is going to end up there. Okay, so now X is going to go to, it's going to be 4, 2. You swap the coordinates, and first quadrant's positive, positive, so that's 2, 4. Y is negative positive, it's going to second quadrant, which is positive negative. Swap the coordinates. This should be Y should be negative 2, negative 4. That was a mistake there. So it's going to go to, swap the coordinates, let's go to negative positive, so that's negative 4, 2. Let's actually get these points plotted as we're doing this so we don't forget that. So I've got to put in 2, 4 here. That's X prime. Then I've got to put in Y prime is negative 4, 2, which interestingly enough is right where X was. That's going to be Y prime, shares that point with X, and then Z, swap the coordinates, so that becomes 1, 5, and in Z is going to Q3, so this becomes -1, -5. So -1, -5 puts me right here, and this is going to be Z prime. Now I take my ruler or straight edge, whatever, and let's get a line we can actually see. So we connect our points. And this is rotating my figure, my triangle, original triangle, which we call the pre-image, to this image here, which is the blue triangle. So that is a 90-degree rotation about the origin. Okay, in my last example, rotate segment RT 270 degrees counterclockwise about the origin. So counterclockwise again is this way. So we're going from Q2 to Q3 to Q4 back to Q1. That would be a 270 degree rotation. But it's a lot easier to go just 90 degrees clockwise, because 270 degrees counterclockwise is equivalent to 90 degrees clockwise. And that's what we're going to do. We're going to do 90 degrees clockwise. So let's get the coordinates of t first. That's going to be -9, 2. Then r is going to be -6, 5. So then notice both these points are in quadrant 2, so I'm going to make the note that quadrant 2, Q2, is negative for x, positive for y. And then Q1 is where we're moving this thing to, is going to be positive for x and positive for y. So what we do, again, we swap the coordinates. This becomes now 5, 6, but in the first quadrant x and y are both positive, so it stays as 5, 6. Then t becomes t prime, which will be 2, 9, and x and y are both positive in the first quadrant, so it just stays as 2, 9. So let's plot our new points. So we have r prime, which is 5, 6. Then we have t prime, which is 2, 9. Then we take our straight edge. And we connect our points, and that is our rotation of 90 degrees clockwise. So we're going 90 degrees clockwise, which is the same as 270 degrees counterclockwise. Okay, so this is a practice. After I read this, stop the video and see if you can do this on a piece of paper. So you're going to rotate triangle XYZ 90 degrees counterclockwise around the origin. And I've given you a table here you can complete the points. Okay? Alright, let's take a look at what we got here. So I'm going to move this. So X has coordinates of -5, 3, and that's in quadrant 2. Let's make a note of our quadrants while we're at this. Quadrant 2, which is negative, positive. Negative for x, positive for y. We're going counterclockwise, so we're going to move x is going to be in quadrant 2, okay? X prime is going to be in quadrant 3. We're moving it from 2 to 3. So quadrant 3 is going to be, let's make a little more room for that. Quadrant 3 is going to be negative, negative. Okay, so let's take care of that while we're doing it here. So we're going to swap the coordinates. So that's going to be 3, 5, but since you're in Q3, it's going to be -3, -5. And let's plot that point x prime. -3, -5 puts me right here. So that's x prime. Now y prime is in quadrant 3, or y is in quadrant 3, but y prime is going to be moved one quadrant over this way, so this is being quadrant 4, which is positive, negative, so y prime is going to be over here, and the coordinates of y are -6, -5. So we swap the coordinates, and in the fourth quadrant, x is positive, y is negative. So y prime is going to have coordinates 5, negative 6. So that's y prime right there. So then z is in the 4th quadrant. It's going to go to the 1st quadrant. So we got to go. So in 1st quadrant again, Q1 is positive, positive. So z starts in the 4th quadrant. I'm sorry, and goes to the 1st quadrant for z prime. So z has coordinates 1, negative 2. So we swap x and y, and we keep it positive in Q1. So z prime becomes 2, 1. So let's plot that. Okay, now we take our straight edge and we connect our points. And this is our rotated triangle. X goes to x prime, y goes to y prime, z goes to z prime. And this concludes the video. So if you found this video informative and you liked it, please give it a thumbs up and consider subscribing to my YouTube channel, The Math Dog. You may share the content of this video with others.